All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Woo, woo. Warm up 87's on the screen. Let's get started, please. Copy and go. Check with the neighbor, see what they got so I can call on someone. All right, good conversation. Number one. Let's see. Let's start over here. How about Lorena? What'd you get for number one? Y equals negative x minus 3 is correct. Double check your work, please. Number two, the parent function of that one is going through the point of origin, and it looks like this, which means, which means our parent function is f of x equals x cubed. So what am I going to do to that? Tell your neighbor, please, before I call on Alyssa. All right. Alyssa, what am I going to do? Move it down 3 with a... Yes, that is correct. Or in other words, the vertex, since the x, there's nothing here on the left side, on the right side of it, and it's no parentheses, that means it's 0, and k is negative 3. So 0, 0 becomes 0, negative 3, yes. Factors for 3a. Pass them one, Alyssa. X plus 3 and x plus 2. Hands if you got that. Looks about right. How about for 3b? Pass them one, Christina. I'm not. X plus 3, 2x plus 1, that is correct. Quotient for number 4. What'd you get for number 4? Tell your neighbor before Anaya pass someone. Probably. Be nice. Bye. Anaya, pass someone. Who? Diego. Which one? Romo. Number 4. Like that? Hands if you got that. That is correct. And we need a solution for the system. Pass them one before you pass it. Share with your neighbor your solution for that one, please. Before Diego pass it to someone. All right, good conversation. Diego, pass them one. 3, 2. Hands if you got that. That is correct. Now, it said to solve by substitution, but let me give you a quick forward as to where we're going with the next type of solving systems using combination or elimination. Look up. Let me show you the elimination process. And some of you remember this because you did this in algebra 1. Here goes elimination. Look up. X plus x, y minus y, 5 plus 1, substitute that into one of these. So we got 3 plus y equals 5, minus 3 from each side, and that's how we get 2. That is elimination method. You're like, what? What? Yeah, we're getting there. Copy the agenda, please. Warm up number 87, systems of equations, and play sheet, tonight's home play sheet. It's in Canvas, and you're going to do numbers 1 through 10, odds only. Make sure you turn in your warm up, please, on Nearpod. All right? So, warm-up 87, systems, and play sheet numbers 1 through 10, odds only. Last night's home play, pages 197, 198, evens only. It's a gift from me to you. Thank you, Mr. Q. However, I did hear some of you had problems. Get it? Like problems for home play problems. So we're going to go over some of those parts. So get a Cornell note ready, please. Hurry up, hurry up, hurry up. Give you some time. All right, here we go. Our objective for today, I can solve systems of equation, linear and quadratic. So here goes one more time. Maybe I went a little bit too fast yesterday, or maybe some of you weren't paying attention to some of the words out of my mouth. Let me repeat that again a little bit slower. Yesterday, I said for systems of equations, there's 3 different ways of solving them. They were by graphing, substitution, and elimination. And I said we're going to focus first on graphing and substitution. We'll get to elimination fairly soon. Here's where some of you didn't really hear me. I said when solving quadratic equations, this is not systems, there's 5 different ways. Is that correct? Yes? And then I said, out of those 5, guys, I think I remember when we covered quadratic equations, I said one of those methods is known as a universal key. And I think I gave you the example of the custodians or people that come on campus that they have a key that opens everything. You guys remember that? Yeah? So here it goes. Out of those 5 ways, imagine, look up to the screen, imagine you get dropped off on top of a mountain, this entire class, there's no bushes, no caves, there's no way down, and you want to poop. There you go. So they give you the equation 0 equals x squared plus x plus 1. And they ask you to solve that. Well, by looking at it, we can't use square roots because that's for binomials. Graphing, you can do graphing, but some of you forgot what that is. Completing the square, you can complete the square. However, if we go with factoring, let's see, what is factors of 1 that add up to 1? Is there such a thing? No. So for home play, you ended up with something like that on some of your problems where you couldn't factor anymore. So what do? Poop on our pants? No. We use a quadratic formula. The quadratic formula solves or gives you a result for any quadratic equation. Now, will the result be a real solution? No. For sometimes you're going to get imaginary solutions, meaning that there is no solution or real solution to the quadratic equation. I'm just giving you that in passing. All right. So, good recall this time? Yes? You guys paid attention this time? Yes? All right. Let's continue. So with that said, type in a definition, 30 seconds. Don't look at your notes. 30 seconds. Go. All right, so solutions for systems. I'm going to write 2 solutions, 1 solution, 0 solution. Solutions. All right, and to the right, I want you to make me 3 small coordinate planes. They don't need to be numbered, just like so. For each of those. going to start with two solutions. I'm going to start with a parabola in blue, parent function. Here it goes. There it is. That's the parent function of a parabola. Then I'm going to sketch a linear equation in red with a positive slope. Here it goes. Let me zoom in case you don't see it. There it is. How many times does the red one intersect the blue one? 2. 1, 2. That's why that one is two solutions. Let's do another one. Parent function, but I'm going to move it to the right and up over here. And let's see. And I'm going to write a linear equation, but I'm just going to write, imagine that it's y equals 10. So here's 10 right there. And if there's a line going through there, y equals 10, so then it should look like this. Do you agree? Yes? How many solutions? 2. Also, it intersects twice, here and there. Whoop, sorry. Let me zoom out. Let me do another one. I'm going to take the parent function, move it to the left, and invert it. There it is. And I'm going to sketch a straight, not a straight line, but a linear equation with a negative slope. So negative slope, like so. How many times does it intersect the blue one? Twice. Once, twice. That's why all of those are examples of two solutions. All right, let's move on to one solution. All right, this time I'm going to start with my parent function. I'm going to move it up, but upside down. So here it goes. There's my quadratic. Let me zoom in. There it is. And for it to only have one solution, I'm going to sketch a positive slope linear equation that barely touches the parabola. There it is. If it barely touches, that means that it's only going to touch at one point. That's one solution. Next, I'm going to sketch a parabola parent function, and I'm going to move it to the bottom right over here. And I want to sketch a straight line going through y negative 4, let's say about right there. It barely touches, so that means there's only one solution. And you make up one, please. Make up one with only one solution, please. I'm going to make one with a negative slope. One solution. All right, let me zoom out. All right, so far so good, yes? All right, so let's go with 0 solutions. Sketch your parent function of a parabola through 0, 0. And sketch a line going through y equals negative 5. How many times do they intersect? None. That's why it's zero solution. Let's flip the original parabola and move it to the right, up. And I'm going to sketch a positive slope line. There it is. Is it touching? Let me see. No. How many solutions? None. And you make up one more by yourself. And I'm going to send you the screen so you can send me your notes. Copy that one on your paper. Example, Michael Jordan Q. It says solve the system by graphing. Today I'm going to focus on the graphing portion. I think we did pretty good with the algebraic portion, using algebra to solve. I know some of you got stuck in certain places, but hopefully now you realize, oh, I can use a quadratic formula. All right, so there you go. However, for the graphing, I did sense some of you struggled with this portion, so I'm going to hopefully address a couple things with what we do today. So we got solve the system by graphing. We got y minus 3 equals parentheses x minus 1 squared, and 2x plus y equals 5. All right. So with that said, let me forward my screen. All right. So here we go. On the right side, I want you to make a coordinate plane. Make sure you make it nice and neat, I guess. So like that, it's scaled correctly. So like that, when you get to the graphing, hopefully you're a little bit more accurate. I'll give you some time for that. Set that up, please. So with that said, y'all ready? Here we go with blue. I'm going to start with blue, but before we start, question. What is the first thing I ask you to do when setting up for graphs? Tell your neighbor. Yeah, they need to be equal to what? Y. So the top one, what do I do to the top one, everyone? Plus 3 plus 3. So my new equation is y equals, parentheses, x minus 1 squared plus 3. Now, I purposely did that yesterday in class, setting you up so that it's equal to y, and I said, hopefully their noodle kicks in. They're thinking a little bit more outside the box, and they see it. Hopefully we did. Let's go to the second one. What do I do to the second one? Subtract 2x, subtract 2x. So we're left with y equals negative 2x plus 5. All right, and this is my new system. Now, before we start graphing, yesterday in class we started with the red one because we know how to graph that one. And for the quadratic, we used the table. Is that correct? All right. However, I gave you these to see if you actually saw what I saw, because I gave you plenty of practice on the warm-up. So question. What would be the parent function of this blue one? Tell your neighbor, please. If you were to tell me f of x equals to what? Everyone? X squared. So let's plot 0, 0 with your pencil, because we're going to erase them. 1, 1, 2, 4, negative 1, 1, negative 2, 4. And now we're going to move those 5 points according to this transformation. Tell your neighbor where we're going to move them. Everyone? Up 3, and what else? And 1 to the right. So that means they go 1 and 3. 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 And now we graph our parabola for that one. You're like, what? So I didn't need to make a table? You could. Just, you're going to do more work. Let's erase the bottom points. and there's the blue one. Let's go to the red one. Where do I start graphing on the red one, everyone? Circle the positive 5, so we start at 5 of y, right there. What is my slope? Negative 2 over 1. That means 2 steps down, 1 to the right. 2 steps down, 1 to the right. Plot your point. Do it again. 2 steps down, 1 to the right. Plot your point. Do it again. 2 steps down, 1 to the right. Plot your point. Now let me go the opposite direction. Here it is. I start at 5. Instead of going 2 down, 1 to the right, I go 2 up, 1 to the left. 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 And what I do that so I can have a more accurate graph. And by the way, this was straight from your home play last night. You're like, what? I know, right? Am I right? Am I right? And some of you had headaches or whatever. All right. So with green, put a big green point where they both intersect, the blue and the red, there, and write your coordinate. What is this one? This is negative 1, 7. And what is this one? 1, 3. Those are my solutions. Solutions. You're like, what? What? Yes. So for home play, make sure you're thinking a little bit outside the box. Now, once again, could we have made a table for this and plotted a bunch of points and done a lot of work? Yes. But put into practice what you know already. Transformations. Thank you, Mr. Q. All right, send me your work. Let me send you those. All right, so Star Wars Q, example Star Wars Q, solve the system by graphing. And once again, I'm focusing on the graphing because this is where I notice a disturbance in the force. So hopefully this is clarifying things. So we are given the system y minus 5 equals parentheses x minus 2 squared. And we got x plus 2y equals 6. All right, so by now, obviously, everybody knows that we need to set each one of those equal to y. Is that correct? All right. So can you give us the first equation already transformed, Joel? Y equals what? I'm sorry? X minus 2 squared plus 5. Hands, have you got that? All right. The next one. Let me just show you because some of you are going to get a little confused with this one. Subtract x, we end up with 2y equals negative x plus 6. What do we do next, everyone? Divide by 2. So my new equation is y equals, pay close attention to this one, let me zoom in. What's the invisible coefficient right here? A 1, is that correct? So what is negative 1 divided by 2? Let's write it as a fraction. Negative 1 over 2x. You able to see what I did? Negative 1 divided by 2 is negative 1/2. And then what is 6 divided by 2? That is positive 3. All right? So that's my new system. All right? So I'll give you a little bit extra time so like that Joel can pass it to someone. And then we're going to see the graphs. Go. All right. Joel, can you pass someone so they can give me the points for the new transformed parabola? Just give me the point so I can plot them. What is it? 2, 5. That's a new vertex, yes. 1, 6. 3, 6, okay. That is correct. Hands, have you got that? Yes. Let's go. Or in other words, if you look at this, our new vertex would be 2 and 5. You took the parent function and moved it to 2, 5. There it is. All right. Next, pass someone so they can help me graph the linear. Jose, where do I start? Y-intercept 3, okay. Plot your point, do it again. 1 down, 2 to the right. Plot your point, do it again. 1 down, 2 to the right. Plot your point, graph your line. Say never the solution for that one. Everyone? No solution. That is correct. So if tonight you end up with stuff that looks weird like this, don't think you made a mistake. Just write no solution. That make sense? Yes? Yes, Mr. Q, we love these. All right. Now, let me show you something really quick that you're like, it's hidden in there. Hopefully you see it. Look up to the screen, writing utensils down. I'm going to take this equation and write it, but with this on the left and this on the right. What does that look like? Tell your neighbor, please. What does that look like? Oh, x minus 8 squared equals 4p y minus k. Wow. Come on, people, let's go. We've been graphing these like all week, last week. You're like, it's a lot of work, Mr. Q. I know we need the focus, the vertex, the directrix, and all this and that, but can we graph that? Yes, we can. Okay. So, with that said, copy this next one, please. Example number 2 on your paper. Example number 2 says solve the system by substitution and graphing. Right now we're still focusing on graphing. They give us y equals x squared minus 2x plus 1 and y equals 2x plus 1. And if you guys notice, this is already solved for y both equations. So, I'll give you some time to set up your coordinate plane. Make sure it's nice and scaled. All right. Now, let's look at this equation of the quadratic. Y equals x squared minus 2x plus 1. Is it in transformation form? Look at it. Could you tell what k is and what h is just by looking at it? No, because it doesn't look like this. Okay. Is it in vertical or horizontal equation form like this? Let's see. No. So what do we do then? Well, then, Mr. Q, I guess I get a table started. -2, -1, 0, 1, 2. And for the sake of time, I'm going to go a little faster. I'm just going to put the equation right here, y equals parentheses squared minus 2 parentheses plus 1. I'm going to use blue. Here we go. Follow along. My first value is -2. What is -2 squared? 4. What is negative 2 times negative 2? 4. Bring down the plus 1, so this is 9. Go to the next one. Negative 1. What is negative 1 squared? 1. What is negative 1 times negative 2? 2. Bring down the plus 1, so this is 4. Next value, 0. What is 0 squared? Negative 2 times 0. So that leaves us with 1. Next one, 1. What is 1 squared? 1. What is 1 times negative 2? Negative 2. Bring down the plus 1. 1 plus 1 is 2 minus 2, that's 0. Next, 2. What is 2 squared? What is 2 times negative 2? Bring down the 1. So the 4's cancel and we're left with. And who noticed now, look up, that the number started repeating? Yes? Do you guys see it? So that means if I was to write here the number 3, tell your neighbor what number I should write for x. Everyone? Everyone? That is correct. So if I was to add one more number for x, what would be my next number there? 9. So let's plot those. Negative 2, 9. Negative 1, 4. 0, 1. 0, 1. 1, 0. 2, 1. 3, 4. 4, 9. All right. Next, help me graph the second equation. Jaden, where do I start? Positive 1 of y, which is right there. And then go up 2 and 1 to the right. 2 steps up, 1 to the right. Plot your point. Do it again. 2 steps up, 1 to the right. Plot your point. Do it again. 2 steps up, 1 to the right. Plot your point. Graph your line. And does everybody see the solutions to that system? Tell your neighbor the solutions, please, to make sure they got it. The first one is what? 0, 1, is that correct? And the second one is 4, 9. For the sake of the video, I'm going to stop the video here, but the rest of you are going to send me your notes right now. In a second.